pre-algebra, we are going over PO61, which is solving multi-step equations. And you recognize some of this stuff from what we did in PO60. You know, in PO60, we had 6x plus 4x, right? In PO60, we had negative 8x plus 5x. We had 7 plus 10n plus 3 minus 2n, right? And your job was to simplify that. I said in PO60, we aren't solving for the variable because there's no equal sign. Well, guess what? Now there's an equal sign, okay? So the multi-step equations, a multi-step equation involves simplifying first, okay? A multi-step equation requires simplifying before solving, okay? A multi-step equation requires simplifying before solving. Now, you've solved one-step equations before. You've solved two-step equations before. These, once you simplify, it's going to give you a one-step equation to solve or give you a two-step equation to solve, okay? And simplifying, what are the two things that we learned about on how you simplify an expression? What do we do in PO60 over and over and over and over again? What were the two things that we did in PO60 to simplify? Yes? Combine like terms, and what was the other thing? Combine like terms is the one with the parentheses. Where you blank what's on the outside into everything in the parentheses. What was that called? It was a property. Distributive property. Okay? So those are the two things, those are two ways we learn to simplify. Once we do that, then we go to solving. And remind me what the method that we use to solve an equation is. Right? To simplify, we combine like terms, we distribute. What do we use to solve? What? Opposite operations. Greg, you're on fire today. Excellent. Okay? Opposite operations. So first we simplify, then we solve. Okay? That's the goal of PO61. And the first way of simplifying, combining like terms, the goal is to combine like terms. Okay? Combine like terms to create a one or two-step equation. Okay? Combine like terms to create a one or two-step equation. And once we have that, then we go to solving it. So really, this is not anything new because you've combined like terms before. You've solved equations before. Now it's just putting those two things together. Okay? It's like you've had mac and cheese before. You've had barbecue sauce before. But when you put those two things together, what you get is something truly magnificent. And that's what we're doing today. Nothing new, just putting things together. So the first one, 6x plus 4x. Okay, we're not going to start solving yet because we can simplify, right? What does 6x plus 4x simplify to be? 10x. And so once you do that, now you've got the equation 10x equals 50, which of course is a one-step equation. And now that we move to the solving phase, how do we solve for x using opposite operations? You can probably do this mentally, which is excellent, but mathematically, what do we do? Josie? Divide both sides by 10. The opposite of multiplying 10 and x is dividing by 10, and we get x equals 5. Okay? Sometimes a common mistake that folks make is they want to jump to the opposite operations first, and they'll like subtract 4x from the 6x. They think that's what you're supposed to do when you solve an equation. Well, no. We're simplifying first, then we use the opposite operations once the like terms are combined. Okay? You only use opposite operations when you're moving something from one side of the equation to the other. We're not doing that here. When we add 6x and 4x together, we're not moving anything. We're combining them, right? And then you can check this pretty easily. If x equals 5, how much is 6 5s? how much is 6 5s? You find 6 $5 bills on the ground. How much money do you have? 30, right? And then you find 4 more 5s on the ground. How much is that? 20. What's 30 plus 20? 50. Okay? So you can check these answers really, really simply by plugging that value back into the equation for the variable and seeing if the equation is true. Right? Next one. Negative 8x plus 5x equals negative 12. What can we simplify? Simplify phase first. What do we got? You realize you have more time to work on your homework at the very end. If we don't have to pause for 20 seconds, will I wait for someone to... If I know you know this, wait for someone to give me the answer, right? Yeah.
Negative 8x and 5x.
All right, and what is negative 8x and 5x?
Wait, hold on. Oh yeah, negative 3x.
Negative 3x, right? Negative 8 plus 5 is negative 3x. And once again, we've created a one-step equation for ourselves. Now we move the solving phase, divide both sides by our coefficient, divide both sides by negative 3, and x equals positive 4. Okay? Which, again, checks, right? If you have negative 8 4s, that's negative 32. You add 5 4s to that, that's 20. And negative 32 plus 20 does equal negative 12. Right? This next one is going to give us a two-step equation because we can't combine everything, right? We've got some like terms and then some not like terms. What does 18n minus 10n plus 2 simplify to be? 18n minus 10n plus 2. Landon.
8n plus 2 equals 90.
Excellent. 18n minus 10n. 8n plus 2 equals 90. Now, for this two-step equation, what do we do first? Two-step equation, what do we do first? We've had two-step equations on our bell ringers recently for a reason, right? Because they're coming back a little bit. You see the operations in the equation. We're multiplying n by 8, and then we're adding 2. So we have to undo that. We're now in the solving phase, right? We did the simplifying. Now we're solving. Where do we start? Where do we start? Yeah. Subtract 2. Start with that constant. Start with the term that's not attached to the variable. Okay? Because we want to figure out, what is 8n so that when we add 2 to that, we get 90. Well, 8n has to be 88. So when we add 2 to 8n, add 2 to 88, we end up with 90. Right? 2 minus 2 cancels that out. 90 minus 2 is 88. And now we divide by our coefficients. Divide by 8, divide by 8, and 88 divided by 8, and is 11. Okay. Try that last one on your own. I'll give you a hint. There are two groups of like terms here. I'll underline them for you. Okay? But combine those like terms. It'll give you a two-step equation. And then you can move the solving process of opposite operations. All right? But just give this one a shot first. And then I'll ask for the bold and the brave and the courageous to share their work. If you did not turn in your math packet yesterday, they were due. I'm not going to take points off for being late, so it's fine if you didn't, but just make sure you get that to me sooner rather than later. One more thing off of your plate. So once you simplify, then go ahead and try to solve it. The process is the same as we did in the previous one, right? Start with that constant. Start with that constant, move it to the other side. Second step, multiply or divide. Speaking of math packets, anybody want to be put on my summer mailing list for math packets being sent to you? 1 a month? Saves me a postage. Okay, so what do we combine this to be? What's our two-step equation? After you simplify, after you combine like terms, what's the two-step equation that you are solving? Who's bold, brave, courageous, and confident? Gregory, what'd you get? Not the final answer, just what after you simplify, what's the two-step equation that you end up with?
8n plus 10 equals 2, and then subtract 10, which gives you 8n, which equals 8n equals -8.
Okay, so yeah, I'll just pause you there. 8n plus 10 equals 2 is where you start. Okay, 10n minus 2n, don't forget about that sign. If you put 12n here, then you add it to instead of subtracting 2n from 10n. The reason why we subtract is because we're combining like terms. We're not using opposite operations yet, right? So 10n's take away 2, 8n's are left, positive 7, positive 3, those constants combined to be positive 10. So 8n plus 10 equals 2. Okay, excellent. Then Gregory went on to say his next step now that we're in the solving phase, opposite operations, we'll be subtracting 10 from both sides. Because we want to know, what does 8n have to be so that when we add 10 to it, we get positive 2? Well, 8n has to be -8, because -8 plus 10 will bring us to positive 2. And we solve for this by doing opposite operations. We subtract 10 from 10 to cancel that out. We're moving it over to the other side. And now, since we're multiplying, we're going to be we'll be dividing. And -8 divided by 8 equals -1. Equals -1. Okay? Now, I'm going to guess that some people got positive 1 here because somewhere along the way they lost the negative sign. It happens. If you did, fix it. And if you did on a test, again, the beauty of this is you can check these answers. If you got 1 and you went ahead and you plugged that in, you'll find it doesn't work, right? Because 10 times 1 is 10. -2 times 1 is -2. Is 7 plus 10 plus 3 minus 2 equal positive 2? No, it's 18. Right? 7 plus 10 is 17, plus 3 is 20, minus 2 is 18. It's not 2. And so you would get this and say, wait a minute, that doesn't check out. What did I do wrong? Oh, that's right. A negative divided by a positive is a negative. It should be a -1, not a positive 1. Okay? So checking answers not only confirms you solved it correctly, it can also let you know you made a mistake. Right? And when it comes down to passing or not passing an objective, these silly mistakes, losing a sign, things like that, you want to catch them if you can. All right. It's like I'm encouraging you to cheat. If you take your social test on a map, right? You're supposed to match the country names or whatever. You can't look at a map and then check your answer, right? That's cheating. In math, you can check your answer, and I want you to do it. It's beautiful. Okay. Questions on this? All right. Let's go to the next type of simplifying that we talked about in PO60, the distributive property. And the goal here is to get rid of the parentheses, right? We know that we're going to need to distribute when we have parentheses. And so to get rid of them, that's why we distribute. To undo parentheses. Parentheses aren't really an operation, right? So there's nothing that's the opposite of parentheses, but mathematically there are things we can do to get rid of them, okay? And our first one here, 7 times n minus 5 equals 42. What's that going to look like after we distribute? Backtracking even further. How do we distribute? Okay. How do you spell distribute? We'll go even further. Penelope.
DIS. Tribute.
Very good, Penelope. All right, now we'll move forward again. What does it mean to distribute? Okay, so to distribute, right, means that you are giving that coefficient of the parentheses, that 7, into each term inside of the parentheses. And when I say give it to each term, what operation are we using? Are we adding 7 and n? Are we subtracting 7 and n? Are we multiplying 7 and n? Are we dividing? We're multiplying. So 7 times n is 7n, right? Whatever n is, we have 7 of them. Okay? And then 7 negative 5s, or 7 times negative 5, is going to give us negative 35. And lo and behold, what have we just created for ourselves here? Nolan.
Solving process.
Yeah, we're now in the solving phase, right? We've given ourselves a 2-step equation to solve. Once you get to a 2-step equation, my goal for you is to feel like super comfortable. You know how when you get home after a long day of school, sports, band, practice, whatever, you sit down in that your comfiest chair, your comfiest bed, with your comfiest pillow, and it's like, I want the 2-step equation to be like the comfiest math concept that there is. You're just like, oh, a 2-step. I can do this. I know how to do this. 2-step equation, right? All this hard work for distributing, combining like terms and whatever, 2-step equation. Right? It's always the same process. Start with the constants. Move it to the other side using opposite operations. Right? We're subtracting 35 in the equation. We're adding 35 to undo that. Because 7n has to be 77, so that when we subtract 35 from 77, our final result is 42. And so now, what do we do?
Divide it by 7.
Right. If 7 n's make 77, what does 1 n equal? Well, 1 n is 11. If 7 of them make 77, one of them has to be 11. And again, just like before, we can check this. If we plug in 11 into our parentheses, now that we know what n is, we can do this first. What's 11 minus 5? What's 11 minus 5?
6.
Thank you. What's 6 times 7? 42. It works. It checks out. Fantastic. Okay, so that's what we're doing here. All right. Give the next one a try on your own. I will remind you that 2 is negative, right? So when you distribute that positive 3, don't forget that 2x is negative. The 9 is positive. Get that 2-step equation first, and then once you're there, once you're in your comfort zone, then go ahead and solve it. Who is bold, courageous, brave, confident on the 2-step equation that you end up with? Gregory.
Negative 6x plus 27 equals 39.
Fantastic. Negative 6x plus 27 equals 39 is a 2-step equation that you should have, right? 3 times negative 2x, negative 6x. 3 times 9, 27. If you put 12 here, then you added 3 and 9, so multiplying. Remember, you were multiplying here, okay? But now, just like all the other ones, it's a 2-step equation. Nolan,
I have the answers.
go for it.
Negative 2.
Are you sure?
Yeah.
You check it?
Yeah.
Good, and you're right. Subtract 27 from both sides, right? Cancel that out. Negative 6x equals positive 12. Divide both sides by negative 6. That coefficient is negative. right? Negative 6 x's is 12. We want to know what 1 x is. And for negative 6 of them to be 12, one of them has to be negative 2. Okay? X equals negative 2. And if you plug that in, so I just love to prove to myself that I've solved correctly here. Negative 2 times negative 2 plus 9, right? Well, we do the multiplication first here. Negative 2 times negative 2 is 4. 4 plus 9 is 13. 13 times 3, 39. Okay, 39. Questions so far? How we doing with this? Ryan, you good? Gregory, you good? Zoe? Regan? Kira? Aiden? Nolan? Anthony? Lily? Tristan?
Yes.
Maya? Landon? Josie? Scarlett? Ellie? William? Mia? Peyton? Did I get everybody?
No.
I'm guessing I didn't say Penelope. Penelope?
Yeah.
Good. Okay, good. Spicy. Okay. For homework for tomorrow. I'm not going to give you a lot. I just want to kind of practice this concept here. I'd like you to do the first 6 on the second page. It does say explicitly the Anthony special. Show your work in the directions and check your answer. Okay, I didn't leave you this much space to write your answer really big. Okay, I gave you that much space so that you can show your work and then check your answer. How do I show my work? Well, look at the notes you did on the previous page. If you wrote what I wrote down, that was showing work. How do I check my answer? Like we did. Okay, what I put up there in blue, when I plugged my answer back in for X to prove that it worked, that's checking your answer. Okay, I need to see both of those things tomorrow for full credit. Penelope.
Okay, so we don't need to do the last one.
No, don't do the last two in the first page. We'll get to those tomorrow. Those are combining both things, so I don't want to talk about those. And that's why I'm only giving you the first 6.
Wait,
Okay.
just these 3? Maybe you forgot about
First 6.
Oh.
Well, I was kind of jumping around the room. Because you answered a question earlier in my head. I'm like, I've talked to Penelope today, but it's my apologies. Sincerely.
I will consider.
Not time for review yet. No, just the first 6 on that second.
I'll consider something. I will take it
Call
into
it.
deep consideration.
All right.
Ryan, did we get
All
a
right.
game yesterday?
You've got 11 minutes to work now. That's how you math.
Okay.
Don't forget to like and subscribe.